Good day to everybody. So welcome back to our video lecture. So I'll be doing now the new unit, and this unit is entitled, still under Module 1, Systems of Linear Equations. So when we say linear equations, these are equations with highest degree or highest exponent equal to 1. When we say systems of linear equations, we have several equations involved, but all equations are of first degree. And under this unit, we have a few learning outcomes. One, solve systems of linear equations by substitution. Two, solve it by elimination. Three, by Kramer's rule, or in some books, they use that as by matrices. Then four, to determine if a system has a unique solution, no solution, or infinitely many solutions. And of course, we will also be applying this in word problems. Okay, but before we proceed with our solutions, let me first explain. So when we say we are after a system, so we will be considering here, we'll just limit our discussion to two and three unknowns. Okay, two and three unknowns. So if we have two unknowns, basically each equation will be given by uh, each equation will be represented by a straight line. And if our line would be intersecting, then this point of intersection is what we call the solution set. So the solution set of the system is an ordered pair. So in this case, if our equations will be in terms of x and y, then this point of intersection is an ordered pair that when you substitute to both equations, it will satisfy both equations. Okay? And solving the system of linear equations, our goal is to find the solution set. So it may also happen that our system will have lines that are parallel with each other. So if lines are parallel with each other, then the system has no solution. While for this one, our system will have a unique solution. And finally, our system may have our lines to be coinciding with each other. So let's say that's the graph of line 1, and it so happened that this is also the graph of line 2. So if this is now the case, then our system will have infinitely, infinitely many solutions because each ordered pair will now satisfy both equations. Again, your system has a unique solution, then when you would like to see it in a graph, the lines will intersect. If your system has no solution, your lines will be parallel. If your system has infinitely many solutions, the two lines will be coinciding with each other. Okay, but we will not be producing here solution by graphing. So let's now start with the first type of solution, and this is by elimination. So the first solution that we will introduce is by elimination. And let's look at an example wherein we have two unknowns. So let's say the first equation is given by 3x minus y equals 2. So let's call that as equation 1. And then let's say equation 2 is x plus y equals by minus 6. This is equation 2. So that's our system. And by the title itself, we will solve it by elimination. So when we say we would like to solve it by elimination, we would like to eliminate a variable from the given system. And how do we eliminate a variable? We can eliminate the variable by adding or by subtracting the two equations given. So adding the two equations together or subtracting one equation from the other equation. So you may choose any variable to eliminate. And what's the easiest way to determine which variable is to be eliminated? In determining which variable is to be eliminated, make sure that you can find, or if you cannot find, you can make a variable so that you can make the numerical coefficients of a variable be numerically equal. So in this case, if you will compare the coefficients for your variable x, we have the first has 3, the second has positive 1, and for y, the first is minus 1, the second is positive 1. So if you will check the variables for your coefficient for your variable y, the first equation is having 1 as coefficient, or negative 1 if you like, and then in the second it's positive 1. Since the absolute values of the numerical coefficients of y are already equal, let's decide now to eliminate y. And in eliminating y, what we can simply do is, since the signs are already opposite, we can simply have equation 1 plus equation 2. And in doing so, if we will now add the two equations, we have, let me just rewrite the equations here. We have 3x minus y equals 2, and then we have x plus y equals minus 6. So if we will just add them, if we will add the two equations together, so we just add the terms involving x together, 3x plus x will be 4x, minus y plus y is 0, and then we have 2 minus 6 is minus 4. And then from the resulting equation, we now have a single variable. In this case, we have the variable x. We can now solve for this variable. So if we will now divide both sides by 4, this gives us x equals minus 1. And then, if we now have the value of one variable, we now substitute this variable in any of the original equations to solve for the other variable. So let's say we can substitute variable x in, I think it's easier to substitute this in equation 2. This will now yield x is minus 1 plus y equals minus 6. Then solving now for y will be equal to, transposing minus 1, that becomes positive 1, minus 6 plus 1 will be minus 5. Therefore, our solution set is the ordered pair x is minus 1 and y is minus 5. So the ordered pair will always come in that manner, x and then y. Like following our alphabet, x will always go ahead before y. Also in your lab life, there will be your x before you ask y, right? So now, how do you check if your solution set is correct? From what we have mentioned earlier, if our system will have a unique solution set, this means this ordered pair must satisfy both equations. Therefore, if you will now substitute our solution set in both equations, it must satisfy both equations. So in equation 1, we have 3 times minus 1 minus y is minus 5. Is this equal to positive 2? So we have minus 3 minus minus 5 is positive 5. positive. What happened?